Welcome to Maths for All. I'm Aisling Flynn. This is complex numbers 1.2. We're looking at complex numbers. So complex numbers have a real part and an imaginary part. Take the complex number called Z, and often names or letters are given to complex numbers, Z or W or Z1 or Z2. And here we're told that Z equals 3 plus 2i. Okay, so complex, the word complex means there's more than one thing going on. Alright, so this complex number Z has a real part, and the real part of Z is 3. So real refers to a real number, just a regular number that you are used to using. You can write it like this: the real part of Z equals 3, and the imaginary part of Z in this case is 2i, and we can write the imaginary part of Z, or the imaginary component of Z, equals 2i. So a complex number can be made up of a real part and an imaginary part. So here we have a diagram showing groups of numbers and where the complex numbers fit in. Okay, this is a set diagram, also known as a Venn diagram. Just to talk you through it, let's begin with the first numbers you encounter when you started this program. They were the natural numbers or the positive whole numbers. Okay, now they're shown here, they're called whole numbers here in this kind of yellow set. Okay, now they are a subset or a set within the integers. So then we met integer Z, which were all whole numbers, but were plus and minus and 0. Okay, so in the full integer circle it also takes in the natural numbers. In the pink area would be the negative whole numbers and 0. Integers then fit within a group of numbers called rational numbers. Okay, rational numbers, when we were looking at them, we're looking at fractions, but indeed integers and natural numbers can be written as fractions. You can put them over 1, or for example 10 over 5, which is a fraction, a rational number, is equal to 2, which is a whole number, 10 over 5. Okay, so they're the rational numbers. There are numbers called irrational numbers. We haven't crossed them yet in this program. We will at a later stage. They cannot be written as fractions. Okay, so they're separate over here. And all of those numbers already mentioned are included in the set of real numbers. Okay, so real. Alright, real numbers, when we did inequalities, you saw that they were solid lines. There was a solid line used to represent them on the number line, meaning they were whole numbers and everything in between the whole numbers. Okay, on the number line. And then we have complex numbers. So complex numbers have a real part. And if you had a complex number that was, let's say for example 3 plus 0i, it would fall in here because it doesn't have the imaginary part to make it fully complex. Purely imaginary numbers would go out here also in the purple area for complex numbers. So that's what that diagram is about there. Okay, so now we're going to add some complex numbers. The rule is basically we add real with real parts, and we add imaginary with imaginary parts. Okay, so not unlike your algebra where you add x's to x's and y's to y's and you cannot combine because they're different. And the same rules apply to subtraction, as subtraction is the opposite to addition. Example, and this is how it is often presented. You're given the names of the complex numbers. Z equals 3 plus 2i and W equals 5 plus I, and to add them we're asked to do Z plus W. Okay, so the first thing you do is you write them down side by side. So this is Z here, and this is W here, and we can identify that's a real part, this is an imaginary part, this is a real part, and okay, my pen is playing tricks, and this is an imaginary part. Okay, you can take a moment if you wish to write real beside real. So here we have real and imaginary beside imaginary. Okay, and then add them together and we get 8 for the real. So now we're going to multiply the imaginary complex numbers. Well, we multiply just as in algebra. Okay, same rules. The only difference is when I squared occurs, we substitute minus 1 for it. So as soon as I squared appears, we'll replace it with minus 1. So simplify the following and give your answer in the form of a plus bi. So this is often asked. It's just describing to you how your answer should look at the end. So it should be a number plus something times I, and you present it like this. Okay, so here's the multiplication we're asked to do. It's a 2 by 2 multiplication. Now you can do it by whichever means you're used to. Okay. You can use a 2 by 2 grid if that's what you like. In this case, I start by multiplying by the 3 first and by the plus 2i second. Okay, so I've just transcribed 5 minus I down here. Okay, so multiplying 3 by 5 gives 15 minus 3i, and then the plus 2i by 5 gives plus 10i, and plus 2i by I gives minus 2i squared. Now this is what I do, and it's a good habit to have. As soon as you see I squared, draw a circle around it. Okay, I squared, because we're going to replace it at the next stage. Okay, so what have I done next? I have written my 15, so 15 goes down to the next line. I've combined my i's. Minus 3i plus 10i gives plus 7i. Okay, and I have replaced my I squared with minus 1. Okay, now the next step is to multiply out minus 2 by minus 1 gives me plus 2. Okay, and the last step is to put the real numbers 15 and plus 2 together, and I get 17 plus 7i with the number first and the I part 7 as requested, okay, by the a plus bi. So that's multiplication, just like algebra. The only difference is when I squares pop I've just up, you replace these few questions to show you how questions can be presented, right? And this kind of notation of having a Z1, okay, so the subscript doesn't do anything, it just is naming the complex number, having a Z2 here, okay, and a Z3 here. All right, now express in the form a plus bi, so we met that in the previous questions. Here it's Z1 with this dot. Okay, we didn't see this before. All right, this dot is another form of writing. Sorry, my pen is playing tricks on me again. Of multiply. Okay, so the dot means multiply. So it's asking me to multiply Z1 by Z3. Now we're not going to go through all of this. So what's it asking you to do? It's asking you to do 2 minus 3i multiplied by Z3 is minus 1 plus 3i. So that's what question 1 is asking you to do. Okay, question 2 is asking you to multiply z2. So transcribe it down and make sure we write it down correctly. So 5 plus I multiplied by z3 minus 1 plus 3I. Okay, so again it's 2 by 2 multiplication, just like the previous example. And question 3 looks a little bit different. Okay, it has z1 multiplied by z2 minus z3. So if you recall your rule of BIMDAS, B is for brackets, you must first figure out what's inside the bracket. So it's z2 minus z3. And when you find that result, you multiply it by z1. So what would that look like? We won't follow it to the end, but we'll develop it a little bit. So it's 3 minus 2I multiplied by, so z2 is 5 plus I, take away, so subtract, we can do that. Okay, subtract z3. So I'm going to use a bracket, as I always like to do with subtraction, and we'll see in the next part why. Okay, so that's z1 multiplied by z2 minus z3. So we have to work out what's in the bracket first. So z1 stays as is. Here we'll have 5 plus I. Now this is why we use the brackets for taking away. Minus 1 gives me plus 1. And minus plus 3I is minus 3I. So you have to apply that take away twice. You're taking away two terms. Okay. Again, z1 is not being used yet. Now here we can simplify. We can put real with real, alright, and imaginary, the i's with the i's. Okay, so real with real is 5 and 1 is 6, and we have plus I minus 3I. So the minus wins by 2. Now, so now you have the preparation work done. Now you have a 2 by 2 multiplication, just like the other examples. Okay, and the last example is I times z1, which was 3 minus 2I, by z2, which is 5 plus I. Now, here we have three things to be multiplied by each other. You can, of course, only do two things at once. Order doesn't matter which two you choose, but let's multiply in that I. So into the first bracket. So I by 3 is 3I, and I by 2I is 2I squared. Okay, and we haven't used the last bracket yet. Now, what's that? It is an I squared. So as soon as it pops up, you're going to replace it, okay, because it simplifies things. So 3I minus 2 by minus 1. We still haven't used our 5 plus I. Okay, so this would be 3I. Now minus 2 by minus 1 becomes plus 2. Okay, by 5 plus I. And now you have a 2 by 2 multiplication, just like the others. Here we have many i's multiplied by each other. You can pause here. This table is worth exploring, and you can work those out to the end. And it came up in various exam questions in complex numbers, but also in number patterns. Okay, or you can use things about number patterns to help you with this. So firstly, I times I is I squared. Alright, and it says equals, well, we know what I squares represent. It equals minus 1. Okay, now 3 i's by each other is, well, an I squared multiplied by an additional 1. So if we take the result from the top line of our table and multiply it by an additional I, we get minus 1 times I, or minus I. Okay, now if we go again Now there's a few ways you can look at it. We can take each additional row and we can multiply it by I. So if we take the second row here, multiply it by an additional I, we'll have minus I squared. Now minus I squared, where can I write this? Well, I'll write it in here. Minus I squared is equal to minus 1, which is of course plus 1. What other way could you write it? Multiplying by an additional I would be I squared by I squared. There's 4 of them, so that could be an I squared by an I squared. Or a minus 1 by minus 1, which gives you plus 1. Okay. Now moving on down, each time you have what came before by an additional I. Okay, so multiplying my plus 1 by an additional I get plus I. Okay, so how would you write that? Well, it's like I times I squared times I squared. So an additional I there, or it's I times minus 1 times minus 1. Okay, and then at the bottom one, if we take them as I squares, that's I squared by I squared by I squared. And that's equal to minus 1 times minus 1 times minus 1. Okay, so it is minus 1 by 1, minus 1 is plus 1 by a minus 1 gives me minus 1. Okay, or if I take the result from the previous row, multiply it by an additional I get I squared, and of course I squared is minus 1. It's the same. So here you've got a repeating pattern now, and you'll find that yes, it does continue like that. Okay, it continues. After minus 1 will come minus I, after that would become plus 1, and after that becomes plus I. Okay, so just looking out for the powers of I, if you can break them up into I squares, each I squared is minus 1. Okay, lots there, like and now it's time for you to do it. You have a quiz called Complex Numbers 1.2. You do that, and you've written exercises of the matching name.